Good day. So today, the Climate Consortium, is launching a global report. A global report that's called Climate Change and Epidemics. It's a synthesis report of 2025 that's going to be presented at the COP in Brazil in the next few weeks. So this report, it is a partnership. It's a partnership to protect the world. We have around like 20 co-funders that funded the Climate Consortium, and that it is some of the groups in the world that are most used to respond to outbreaks and epidemics. So here we have the top experts in the world working together between academia, industry and government to create a program that can really respond to new outbreaks that emerge, especially from climate-sensitive diseases. But this program also built a very large workforce. So in the last 3 years, we created a large fellowship program. We have hosted like 862 fellows from 52 African countries. And that when they come to our labs to get very advanced training on how to adapt the lab protocols and tools to respond to the outbreaks. And what's happened is that when the fellows go back to the country, and you're talking Africa alone of 52 countries, that they get access to all the laboratory protocols, the tools, and they receive reagents to respond to the new threats. So what we have is created this very large workforce. And this is not an option. Working together in a large consortium is the cornerstone of public health. So as one of our fellows, Dr. Alex Duran-Kai from Cameroon highlight, climate change accelerates the spread and severity of infectious diseases. Building resilient capacities in surveillance, research, and health systems is no longer optimal. It is the cornerstone of protecting vulnerable population and ensuring a global health security. So it's really important that we work together to respond to the pandemics, and to the new epidemics. Why that? What's the big warning? We know that from very accurate data that the climate change has the potential to aggravate over 50% on non-pathogens. So what we are talking about, over half of our disease being amplified by climate change, getting the perfect storm between climate extreme events and then infectious disease. And how that happened? That happened between four main mechanisms that this report highlights. The first one, and I'm going to be taking you quick, is about the gradual temperature rise. As the temperature rise, you have vectors that start going to areas that they were not before. We are talking about mosquitoes and ticks, for example. We also have evolution of pathogens, Unfortunately, what happened with COVID, that during the pandemic evolving many variants, it's happened to many pathogens at the moment, and they evolve to be more transmissible and take advantage of this drastic increase in climate change. And then we also have extreme climate events. When you have extreme climate events such as a big drought or a flood, it normally disturbs the environment with new pathogens emerge from that. And the fourth one is what you call climate migrants, which will become very problematic as large populations migrate the effect of both climate change and epidemics. So if I take you quick to the first reason why pathogens are being amplified by climate change, and that's the gradual temperature rise. So infectious disease outbreaks are becoming more common, including in regions where they did not historically occur. So, for example, as we speak now in 2025, West Nile virus is spreading over 20 European countries, which was not normal. And we had a record number of dengue virus infections with over 14 million cases in 2024, and very likely that 2025 will break the record again. So if we go to West Nile virus, which we're going to have a more detailed summary by one of our colleagues, is a climate-sensitive pathogen that has originated in Africa. And this African map shows the main regions that this virus is spread, with two big hotspots, both in Southern Africa and West Africa. And one of the strains have emerged from Senegal, for example, West Africa, and start transmitting globally. We are talking about causing infections in multiple European countries, multiple Asian countries, and multiple North American countries, just highlighting how a pathogen can emerge and spread much further than that. Another disease that is beginning to be very prevalent around the world, but for the first time in Africa, and here's the African map. In red, we show the areas of disease susceptibility to dengue, that now most of Africa is now being susceptible to dengue fever. And in 2024 and 2025, the climate program responded to 14 large outbreaks in Africa on multiple countries, going from West Africa, from Senegal, Burkina Faso, Ivory Coast, Togo, Cameroon, to enter the Horn of Africa in Ethiopia, and then the East Africa with Mozambique and multiple Indian Ocean islands, which really highlighting the highest number of global and African infections ever recorded. The second main reason why these pathogens are amplified by climate change and spread further is when you have the pathogen evolution. Like COVID, pathogens are evolving to spread further. So, for example, in this year, over 500,000 cases of chikungunya, which a new variant emerged and started spreading much further, and influenza virus with birds are flying much further, and together with the evolution of the pathogen, it has been detected infection in over 400 avian species, many wild birds, and multiple mammals. So if you get a quick look what's happened with chikungunya and evolution. So chikungunya was first identified in 1950 in Tanzania, and then it started evolving and causing infections in the 50s in Central Africa. It moved from a first outside introduction from Africa in late 50s, and in 2004 has the main evolution of the virus that create a new lineage in Kenya and the Indian Ocean islands that spread further. And that affected in total over 119 countries. But unfortunately, that evolution, it happened again. So in the end of last year, a new strain of chikungunya evolved with exactly the same mutation that caused the 2004 outbreak, a completely new evolution, which would be a new strain. It emerged in the middle of 2024. It has a large introduction in Reunion, and from Reunion Island start spreading very widely across Indian Ocean islands and other countries. And why do we worry about that evolution? And that mutation or that evolution of chikungunya virus, it allows the virus to transmit much better in not only in the natural host, the Aedes aegypti, but also in alternative host that we call Aedes albopicus. And the albopicus, it will expand, and is in the map in the bottom, to large areas of Asia, including China, to large areas of Europe and North America, really getting now a global potential to this virus. And unfortunately, that's what already is happening in 2025. Not only we have very large outbreaks in the Indian Ocean islands, in East Africa, but the biggest outbreak ever recorded in mainland China, and the highest number of infections in Europe. So the pathogens evolve, but a lot of times we have the re-emergence of pathogens that evolve from something that we have not seen for a long time. So, for example, in the last year and this year, we see re-emerging multiple strains of Marburg and Ebola, and a completely new emergence of a virus that was normally restricted only to the Amazon basin where the COP is being hosted. That virus called Oropouche. Yeah, and Oropouche emerged in a very during exactly with the biggest drought in the Amazon region. So on the left, I have the map of Brazil. Normally, the presence of Oropouche is only in the Amazon basin. But with the drought, what has happened, both the population and the virus and the vector get very close to the big urban areas. And then it moved from 2024 on the graphic on the bottom, on orange and yellow, that's states of the Amazon, follow the drought to cause a massive outbreak on states outside the Amazon, and now is spreading everywhere in multiple states in Brazil, but also in Central America and Latin America, and with a red case in North America. So that the reemergence of pathogens a lot of time not only come from the evolution of the virus, but also from another very important aspect that's between being taken with climate migrants. Yeah. So the movements of people, animals, and cargo can further compound the challenge of climate change and epidemics. Yeah, climate change can drive populations to migrate, cause more interactions with wildlife, and increase the risk of spillover pathogens. And now we expect even worse with El Nino, like to produce severe drought, or in other areas severe rain, which may evolve large migration of individuals. And unfortunately, the main place that's happened, or a place that's very high and is going to be covered by another colleague in more detail, yeah, it is cross-border climate migration. And when it happens at a scale never seen is in the African continent, yeah. And that's problematic, so because a lot of areas in different countries in Africa, severe droughts, yeah, or severe floods, and people is migrating to the areas that has a higher opportunity. So, for example, South Africa alone is receiving hundreds of thousands of migrants, many of them due to cross-border climate migration a year, and is expected to grow very, very, very large, yeah, with many individuals come from Southern Africa to West Africa, moving from the place, and that has a potential to also, this cross-border migration to spill over around the world, yeah, which will generate potentially hundreds of millions of migrants related to climate in the next 50 years, not only from Africa, but also from Asia, from Latin America, and other countries in the world, yeah. So what we have to do to counter that? Yeah, the first thing that we have to do is to work together. Yeah, we have to create programs that can act both between government, public health organizations, academics, and industry, and have a call for action. So what's the call of action that we have? Yeah. First is surveillance. We have to implement strong surveillance systems, not only in humans, but also in animals. Yeah. Second, report outbreak timelessly. Immediate and transparent report is paramount. Yeah, we know what's happened during the COVID pandemic, that a lot of time the individuals that identify the variant, yeah, and report were punished. But we have to continue quick report, and we have to be aware that this is transparent done, that protect who find these outbreaks. We also have to prioritize vulnerable population, yeah, especially in low middle income countries, because if you don't really prioritize them, they will end up as climate migrants. And I know that at this moment in the world, there is a lot of tension about large number of migrants. Yeah. We also have to promote climate resilience. We have to adapt surveillance system and vector controls so we can adapt that to as the climate is changing. And we need to commit sustainable funding. But we have to do that in a very, very efficient way. We know that funding for many programs for public health is decreasing. So more than ever, we have to work together and efficiently to make sure that the funding that exists can really have an important response. So here, and in a few weeks at the COP, we are releasing the Climate Change and Epidemics report, which is a synthesis report for policymakers and for decision makers. It was produced by over 200 scientists from 40 countries, and is not only a report, but that comes with a whole program that provides laboratory assays and software applications to track epidemic amplified by climate change. It also comes with a clear call of action for government, private companies, academics, and NGOs, that through a cross-border collaboration partnership, we can create a more effective global approach to climate change and infectious disease. And to finish with an African proverb, that a stick is easily broken. Sticks in a bundle are unbreakable. And that's what we are trying to do, is to unite many groups around the world on that. So my last words from you that come from really have experience during the COVID pandemic, some of the development of infrastructure in the global south. So for example, we now have some of the best and most equipped labs in the world, and that's why we are really trying to develop assays and tools to predict, track, and control epidemics in the most affected regions in the world. And that is a way that this tool get in the hand of who need the most. And here we are talking about researchers, public health officials, and governments that can use these tools and this knowledge to respond to epidemics as they are emerging. So here during the COP30 and before, we released this program, and in a way that we can really start responding as a global consortium to the dual threats of climate change and infectious disease. Thank you for being here in this launch event. So now in the launch of the report, we're going to bring a team of 4 technical specialists, scientists that will give more information about the different aspects that associated climate change to the emergence of epidemics. So I have the great pleasure to invite Dr. Monica Moyer from SERI at Stellenbosch University, which will be giving more information to you, the viewer, about how the linear increase of temperature it is affecting new epidemics around the world. Welcome, Dr. Moyer.
Thank you, Professor de Oliveira. Hi, my name is Dr. Monica Moyer. When we think of the negative impacts of climate change on humanity, we typically picture dramatic, extreme weather events like fires and floods. Yet it's the subtle, gradual changes in temperature, precipitation, and rainfall that is significantly shaping the spread of infectious diseases, especially vector-borne pathogens such as arboviruses, which are transmitted by mosquitoes. Climate affects mosquitoes and the diseases that they carry in multiple ways. So, for example, higher temperature can increase mosquito activity rates, which affects how often they are biting humans. Increased rainfall can facilitate their breeding, and higher humidity can prolong their lifespans. These factors can then increase the mosquito population sizes, and that can really lengthen and intensify disease transmission seasons. Climate change can also impact mosquitoes and their diseases by allowing them to spread into new regions. Previously unaffected regions are now suffering large outbreaks. For example, in Europe, they're experiencing widespread West Nile virus transmission, with cases recorded from 14 countries in 2025 alone. This growing threat was the topic of this year's World Mosquito Day, where the European Centre for Disease Prevention and Control described record-breaking outbreaks as the new normal for the continent. West Nile virus is an example of a climate-sensitive pathogen that is transmitted by mosquitoes. West Nile virus originated in Africa, but it has expanded into Europe due to long-distance bird migrations importing the virus onto the continent. West Nile virus was also introduced into New York, where it spread rapidly across the Americas, causing tens of thousands of cases. West Nile virus is now considered the most widespread arbovirus in the world. Now, climate change may cause West Nile virus transmission to intensify in Africa in regions where surveillance and control are limited. Considering how interconnected our world is, this virus poses a major global health threat. Although West Nile virus originated in Africa and is endemic to the continent, it remains poorly characterized. In our recent study, we reviewed the available genomic data, and we found really large gaps. Although the virus has been detected across the entire continent, genomic data is scarce. It's only available from a few countries, where large regions of Central, Eastern, and Western Africa remain unrepresented. This limits our understanding of viral evolution and spread. We also identified major gaps in diagnostics and surveillance infrastructure. The tools to track and respond to this virus exist, but equitable access and sustained investment are essential. Considering that vector-borne pathogens are expanding into new regions, it becomes globally important to strengthen Africa's capacity to track this virus. So we call governments and policymakers to action. Governments need to strengthen surveillance by implementing a coordinated One Health surveillance approach that integrates animal, human, and environmental data for early warning systems. We also need to promote climate resilience by adopting climate-informed surveillance systems and vector control programs. These efforts require commitment to sustainable funding, regional collaboration, and strong national commitments to ensure lasting resilience. Thank you.
I also have the pleasure to invite a virus evolution expert to give more information on how the viruses and pathogens are evolving to be more transmissible and take advantage of climate change. Welcome, Yajna Rampal, to this launch of the report. And we look really forward to learn more of the technical details of the virus's evolution.
Thank you, Prof. Tulio de Oliveira. Hi, my name is Yajna Rampal, and today I will be talking about the evolution of pathogens, a climate-sensitive health crisis. The 2025 chikungunya outbreak is a stark reminder of the impact of climate on infectious diseases. With gradual temperature rise, change in precipitation, and the increase in frequency of extreme weather patterns has all created a selective pressure, increasing the emergence and re-emergence of infectious diseases, such as chikungunya disease. Before I begin about the impact of climate change on the chikungunya virus or other arboviruses, let me explain what the chikungunya disease and virus is. The chikungunya disease is a febrile illness that is characterized by a high fever, muscular and joint pain, headaches, fatigue, nausea, and rash. The chikungunya virus is an alpha virus belonging to the Togaviridae virus family, and the disease is transmitted by infected Aedes mosquitoes. Chikungunya first originated in Tanzania in 1952, which created the first East Central Southern African lineage, later spreading to Central Africa and then Asia, creating the Asian lineage, which then spread into the Americas. In 2004, a huge outbreak occurred in Kenya, leading to the emergence of the Indian Ocean lineage, which had drastic epidemics in the Indian Ocean basin as well as Asia. The 2025 global chikungunya outbreak re-emerged in Reunion Island in August 2024, later spreading to neighboring islands such as Mauritius and Mayotte, with transcontinental spread into Italy, France, then Asia, causing one of the biggest outbreaks in China, with over 16,000 cases recorded. So how does climate change drive the expansion of diseases? The resurgence of chikungunya was driven by the ECSA genotype, which is intrinsically linked to climate change, which has extended the geographical range and length of the seasonal activities of the Aedes mosquitoes, which is the virus's primary vector. The resurgence demonstrates the capacity and adaptation of the virus to changing climatic realities, rewriting geography of the arbovirus transmission. So what do we need to do? We need to help strengthen surveillance by integrating weather, vector, and genomic data to help predict and stop epidemics. We need to commit to sustainable funding by investing in diagnostic, vector control, and trained personnel by increasing the capacity to respond to these outbreaks. We also need to prioritize our vulnerable population by ensuring equitable vaccine access and enhance cross-border surveillance. Together, we can stop the re-emergence and emergence of infectious diseases. Thank you.
We are also very fortunate to have another global expert, come from Ethiopia, from EPHI, Dr. Dessalo Mogas, and he's going to be talking to us about how to both measure, but also how to work with climate-induced migrants. Welcome to this launch, Dr. Dessalo.
Thank you, Professor Tulio de Oliveira. My name is Dessalo Meseret Mogas. I will be talking about climate change and human migration in Africa, specifically by focusing on its implication on infectious disease risks. So, climate-induced migration is one of the impacts of environmental disasters or climate change, which is significantly reshaping the movement of people within and across national borders. Even though climate change is mostly considered as the coping mechanism for people to cope with climate stresses, it also increases health risks, mostly through transmission of infectious disease. So understanding the interaction between these three, climate change, human migration, and infectious disease, is crucial for planned public health planning and for policy making. Africa is one of the most climate vulnerable regions in the world, with average temperature rising faster than the global average. Projections suggest that by 2050, mid-century, Africa will see the warming by 3 degrees Celsius. Despite the fact that the continent contributes only little, that is less than 4% to global greenhouse gas emission, it suffers disproportionately high impact from climate change, which highlights the climate injustice, that is the suffer of disproportionate impact. So the question is, why is Africa mostly vulnerable to climate change? There are different factors which are interacting and impacting the continent to become more vulnerable, which include exposure to extreme weather, mostly that is connected to the location of the continent in arid and semi-arid places or regions, mostly the Sahel Desert. and the northern countries mostly, and climate-sensitive livelihood dependence, that is mostly agriculture, fishery, and pastoralism, which are very sensitive to climate change, and low adaptation capacity to cope with the challenge and rapid population. So as I mentioned earlier, climate change is one of the key drivers of human migration, both within the country as well as cross-border. The main climate-related factors that cause or that push people to move include droughts, heatwave, flooding, and their collective impact on the lives, livelihoods, and the resilience of the community. Migration decisions are mostly made not by single reason. Instead, there are multiple factors that push people to move out from their home. So in this case, climate change is mostly used as the threat multiplier, which intensifies the already existing societal problems, which are by themselves the factors pushing people to move out. Internal climate migration is one of the pressing issues in Africa, which is the common problem in almost all countries in Africa. Projections suggest that by mid-century 2050, we will see 100+ million people moving within Africa. So this form of, or this type of migration is mostly the response for extreme weather events or disaster, that is the sudden disasters of the climate change, which highly affects women and children. Based on our analysis using the African Climate Mobility Initiative data, it shows that most of the Western and Eastern and some parts of Central and Southern Africa will see most people flowing out and in 2050s. The border regions of the continent will be also the main hotspots of climate migrants, which are already the places for refugees and migrants due to some other reasons. So climate migration into those places will be the main factor, or maybe the reason for infectious disease outbreak. Climate change not only impacts people to move within their countries, it also pushes people to move out of their countries, that is cross-border. So projections show that 1.2 million people will be moving out of their countries by 2050s. As we can see here, our analysis shows that most of the cross-border migration in Africa will be in southern region, as Namibia, the most people moving out, and South Africa, the main destination. So both internal and cross-border migration has significant impact on infectious disease by altering distribution and incidence of their patterns. This can be happen in different pathways, which include exposing migrants to endemic disease areas at the destination, introducing new pathogen by people who are moving, as maybe they carry the virus and transmit to other places, and increasing the outbreak, mostly through overcrowding at temporary residence areas or temporary shelters or camps, and straining local health systems, which already have limited capacity. And also, migration might disrupt routine health surveillance and control. Then overall, this will impact infectious disease transmission significantly. So in conclusion, climate migration and its impact on infectious disease transmission is a pressing issue in Africa, which needs a collective and urgent action, specifically in building climate resilient community by empowering the community to cope up with the challenge by themselves. It can be by enhancing the capacity or by investing on green technology or the green economy that helps them to cope up with the problem. And also it needs prioritizing sustainable financing by integrating climate mobility into national adaptation plans and long-term climate financing strategies. And finally, the high focus and priority should be also given to vulnerable communities, mostly when there is a sudden climate extreme event, which mostly affects women and children. Yeah, this is all. Thank you.
We also have a team of international experts that are online that will be participate of the launch of the report. Yeah. And the first one that I would like to invite is it's Dr. and also Professor Marta Giovannetti, yeah, and she's coming to us all the way from Italy, yeah. So yeah, welcome, Dr. Giovannetti.
Hi everyone. So first of all, let me get the chance to say thank you so much, Tullio, for the opportunity actually to be here, even in a remote way. So I am Marta. I am a researcher from the Osvaldo Cruz Foundation and actually an associate professor in the University of Campus Biomedico in Rome, Italy. So today I'm gonna share with you some of our novel results that we obtained under the Climate Consortium in the context of emerging viral pathogens. So here I am just sharing with you the results that we obtained in the context of Oropus virus. So we do get the chance by performing this kind of extensive genomic surveillance activities all across Latin America to understand how different drivers, including extreme weather events, as well as, of course, exacerbated human activities, they have played such an important role in the expansion of Oropus virus behind the Amazon regions. But just to try to put this into the right context, I want to start to say that, of course, Oropus virus is a negative sense RNA virus, which belongs to the Otobunia virus genomes. Actually, it maintains a sylvatical as well as an urban cycle, where different kind of vectors, they play such an important role for its transmissions, including Cholicogyes parensis mange, as well as Culex, Quinquefassatus mosquitoes. So for a long time, it has been considered kind of pathogen restricted in the Amazon basin region. However, at the beginning of 2024, because of the implementation of a molecular screening approach in all the different central public health labs located in each Brazilian state, as well as in other countries in the Americas, actually, we do follow a kind of huge rise in the number of Oropus cases. So we were like, try to understand the drivers behind this epidemic expansion, which of course include several factors, including viral adaptation, deforestation, population density, and climate change. So under the Climate Consortium, we have been actually, we have been proposing, we try to propose a kind of novel approach for the study of infection diseases that merge not just the real-time genomics production of data, but actually also the integration of other kind of data, including, for example, eco-epidemiological modeling, which might enable us not just to monitor the real-time evolution of pathogens, identify the presence of some specific key mutation, but also try to understand the potential blind spot, region at risk of transmission, and put in place in this way active surveillance strategies. So under this kind of overview, we do get the chance to obtain more than 150 whole genome sequences for the first time outside and behind the Amazon basin. So for the first time, we were able to describe how the Oropus transmission in Brazil and the Americas was characterized by the presence of two main phases. the one that we call like the phase 1, during the time the pathogen was restricted in the north part of the country, and the one that we consider the expansion phase during the time actually the virus, we follow this kind of southward expansion of the pathogen that was able to reach other countries and other regions behind the Amazon basin. So then by integrating genomics data obtained by other colleagues from other countries in the Americas, including Colombia, Peru, Cuba, and later travel data from Europe, Italy, we were able to describe this kind of large movements which enable the virus to reach also other countries, highlighting how this pathogen is becoming a kind of global recognized emerging threat. So then we do analyze different kind of covariates in order to try to look for drivers behind this rapid epidemic expansion. And we do find evidence that suggests that at least during the expansion phase, different kind of drivers, they were likely associated with these large movements that were related to an increased human population density, and then regions that presented also a lower evergreen broadleaf forest, as well as a region that presented ideal ecological condition for the vector transmission and suitabilities, as well as a region that presented an higher mean temperature, as well as regions that presented, of course, an higher banana as well as cocoa cultivation. So this just highlight how, once again, not just, of course, climate change, but also human activities, deforestation, play such an important role as in order to try to enhance the transmission of these pathogens in other regions. So a call for action, of course. These results just show how, of course, strain genomic surveillance is important for outbreak response, as well as importance of reporting outbreak in a kind of timely way, and also prioritize vulnerable population is also the key. And of course, try to put in place a kind of novel strategy that might enhance the chance to perform active surveillance, or prioritize regions at risk of transmission. Thank you so much.
We also have one of the top global experts on arboviruses. This means diseases caused by mosquitoes such as dengue and chikungunya. And coming and joining us all the way from Brazil, we have Dr. Luis Alcantara that's going to be joining us online and giving a short summary of the situation that he sees, especially in South and Latin America. Welcome, Dr. Alcantara, to this launch of the report.
Hello, my name is Luis Alcantara. I am a scientific researcher from the Oswaldo Cruz Foundation, the Fiocruz in Brazil. And as part of the Climate Consortium, my research group is traveling from Brazil to different Latin American countries to perform local capacity building of genome surveillance. And in Bolivia, there was a recent chikungunya outbreak of the Africa genotype of this virus. It was around 1,200 positive samples, with the most of them collected in June 2025, this year. Taking account the climate, we saw the precipitation of 35%, like 116 millimeter and temperature of 32 grams Celsius. These were higher in the last 5 years. In addition, in our NAVIL project from the consortium, looking for the emergence and re-emergence of pathogens in the riverside community of the Silvetic area of the Brazilian Pantanal biome, you are seeing the increase of mosquitoes Aedes aegypti and Aedes albopictus, compare our collection from the first and from the second year. Here you see when you go to the first year to the south of the river, and here when you are going to the north of the river. You can see that the mosquito, the Aedes aegypti and the Aedes albopictus is increasing compared the 2 years. And this is happened due to the frequency episode of fires with the increased temperature, consequently leading the climate adaptation of these vectors, and also the increase of the respiratory diseases that you also saw. And I'd like to thank you.
So we know that some of the things that you listen here today and that you read in the report, may sound quite worrying, about this contribution of climate change and epidemics, So we do have reason to worry, but we also have reasons to be positive, especially if we do what we did during the COVID pandemic, that we join forces and that we focus in one of our big global health threats, which at the moment it is really, I cannot imagine a bigger threat than this intersection between climate change and infectious disease. And that's why we are working together with hundreds of scientists across the world, to create a program and consortiums that can respond to that. So that's when we can really have an effect. We have that done once during the pandemic. We developed the tools, the vaccines, the diagnostics, the therapeutics. We discover multiple pathogens and variants, and we got out of that. So what we need now is to work together to do that. And please join this movement, this program, and you can get a lot of more information on our report. So to give you information on how to get access to both the report, the tools, and the laboratory assays, and our next steps, I would like to invite here Mambele Kosa, that's the head of our communication of SERI, which will provide you more information on how to get access the report and all the different events that's coming with that. So thank you to be with us and for providing all our viewers with more information on how to get more information on the climate change and epidemics report of 2025.
Thank you so much, Prof. Tulio. And as you have heard, climate change is not just an environmental crisis, it is a public health emergency. So with that said, you can access the COP30 report, which was produced by the Climate Consortium, on our website, which is www.climate.health. You can also access all the materials using the hashtag climate on all social media platforms. Most importantly, we will also be at the COP30 in Berlin, in Brazil, and we hope to see you there. Thank you so much.